Okay, good morning to everyone. In CAD/CAM subject, we are in Unit 3. With the last class, we completed Unit 3, Part A, which is numerical control, and Part B is consists of two parts. One is CNC part programming, and second one is APT. In last two classes, we completed Part A and Part B. First part is CNC part programming. Today in this class, we will discuss about Unit 3 Part B, which is APT. APT means automatically programmed tool. Okay. In APT, we will discuss about what are the statements included in APT and basic programming using APT, automatically programmed tool, and what are the differences between manual method to automatical programming tool. Okay, we will look into this unit APT by sharing my PPT. First of all, the presentation on CAD/CAM subject. This subject is for final year mechanical engineers. Next, we are in Unit 3 Part B, which is APT, automatically programmed tool. Next, first of all, coming to first one, computer assisted part programming, which is APT, automatically programmed tool. Okay, we know that APT, abbreviation for APT is automatically programmed tool. First of all, coming to APT, and what is APT? What is the basic definition for APT? Automatically, we know that abbreviation for APT is automatically programmed tool, but where it is used and what are the classification on it? Okay, what first of all, basic definition about APT. Manual part program. Coming to in this, first of all, I am declaring that what is best over manual part programming or automatical programming tool. First of all, I am declaring that and explaining manual part programming. Manual means it is a traditional part programming, but it takes long time to respond. Okay, it takes long time and tedious and subject to human errors for complex jobs. Why I am stating that in manual part programming there is human in manual part programming there is human involvement is there, but compared to automatically programmed tool, manual part programming is very time consuming process and errors are there. Why? Because in this human involvement is very high because of manual part programming. Then compared manual part programming with automatically programmed tool or automatic programming or CNC part programming. There is a difference between those two. In first method manual part programming, second method is CNC part programming. In manual part programming human involvement is there, but in CNC part programming or APT method human involvement is less. In the ratio of 80% is automatically, then remaining 20% is manually by program. Okay, by using manual part programming methods, human errors always are present by any mistakes, but coming to automatically by using automatically programmed tools and CNC part programming, there is no errors are present by using of CNC part programming or APT. Why? Because that here we are giving the complete data, complete instructions and commands to the machine control unit. Okay, after that The complete operations are all can be done by machine only. There is no human involvement in middle of the process. Okay. Next, machining instructions are written in English-like statements that are translated by the computer into the low-level machine code of the MCU. That means, first of all, we are giving the commands or instructions to the MCU by, first of all, we are giving the statements in the format of English statements, in the format of English-like statements. Those statements are directly sent to MCU. That means machine control unit. It is not understandable. So for that reason, the English statements are translated by the computer. Okay, we are giving the English statements to the computer. Those English statements are converted by using computer into the low level language. Low level language is understandable by MCU, machine control unit. It is used for more complex jobs. Next, APT. The various tasks in computer-assisted part programming are divided between human part programmer and computer. Okay, in this figure, I am showing the flowchart. What are the tasks should be done by, first of all, part programming, programmer's job. Second one is computer's job. Okay, first of all, I'm discussing about part programmer's job. Okay, part programmer means programmer. Here he gives the data. That means what we are giving the data or instructions or commands to the machine control unit. Okay, previously I was told you about that. We are giving the statements like English statements. Those statements are converted by using computer of machine control unit. Here also part programmer means here he gives the instructions to the MCU directly. Then first of all, the tasks can be completed by programmer. First one is defining part geometry. Part geometry is nothing but define shape, size and dimensions of geometry. Geometry means a part. Next, after then defining a part geometry, then he will define tool path. What is the position and direction of tool, and operation sequence. Operation sequence means following an order. First of all, we want to produce any part by following sequence of operations. First, that means, for example, first of all drilling operation, after then milling operation, after then shaping operation. This is the operational sequence. Following, that means following a queue or following a certain order. That is called operational sequence. After then specify other functions like speeds, spindle speeds and feed rates. Okay, these are all the complete operations can be done by part programmer only. After then computer jobs. In 3 steps, he will given the complete data by using manual method. After then, he gives the information to machine control unit by means of computer, using of computer by input method. Computer's job is nothing but, first of all, input translation. We are giving the statements like English statements. Then the computer is translated, or the computer translates the English statements into low-level language of machine control unit. That means machine control unit is understand only low-level language. Okay, it is not understandable by English statements. Then after that, arithmetic and cutter offset computations. Arithmetic means we already know that. What is arithmetic? Means here some mathematical operations can be completed in this stage, and we are calculating some computations. like cutter offsets and etc. Editing phase. Editing phase means in this readable data on cutter location and machine tool operating commands. That means cutter location data. Cutter location data can be calculated in editing phase. Next, post processor. Post processing means converting cutter location data into low level code. Low level code means it is understandable by machine control unit. Which data is understandable by machine control unit? It is low level language and low level code. Next, part programmer's job. In previous slide, we discussed about what are the jobs or what are the tasks can be completed, should be completed by part programmer. First part is defining a part geometry and specifying the tool path and operational sequence. Recently, we completed what are the operations can be completed by part programmer, defining a part geometry and tool path. Next, first of all, defining the part geometry means geometry elements are sometimes defined by only using of specifying tool path. In this, examples of part geometry in definitions. First of all, I am showing that P4 L1 C1. That means P4 is nothing but it is a 0.4. Okay, P4 is nothing but 0.4 that equal to, we are taking any classification here. In this, I am showing that point divided by 35, 90, 0. That indicates we are taken any classification here. I am showing P4 is a point. That means any word that has two classifications here, major and minor. Major word, minor word. Major word consists of, that means direction of subject. It is the subject, and this one is the description. Subject P4 is the 0.4, and then subject is the point, major word, and second one is the minor word. Description is 35 in x direction, 90 in y direction, 0 is z direction. Next, L1. L1 is the line 1. Line 1 is equal to, line is the subject, then description is 0.1, 0.2. We already know that any line can be generated by using of 2 points. That means P1, P2. Here L1 is generated by using of 2 points P1, P2. Then circle. Circle is also, we already know that circle can be generated by using of 2 points. That means one starting point and one ending point. Here I am explaining the process of generating circle. In this process, circle, I am taking one arc. Okay, starting point is this one and ending point is that one, and middle is radius. Okay, here also C1 is the circle. It is generated by using of center radius. P8 radius 30, 0. Next, specifying the toolpath and operational sequence. Toolpath consists of a sequence of points or connected in line and arc segments. We already know that any process can be done by using of point-to-point command method. That means, for example, I am taking drilling operation. For the required part drilling, that means I am taking machine tool. For that, the machine tool travels from starting point to ending point by using of point-to-point command. That means the machine tool starts from one point A, that is A. Then after completion of part A drilling, then it travels from A to B, after then B to C, after then C to D. It is the point-to-point transformation or point-to-point traveling distance. It follows point-to-point command method. In this, go to is the go to direction, forward direction P0. Continuous path command, go left, L2, go left on line 2. Next, tan 2 on circle 1. Tan 2 is nothing but tangent to the circle 1. C indicates circle. L indicates line. P indicates point. Here, go left to the line 2. Go left on the line 2 and tangent to the circle C1. These are the point-to-point command and continuous path command. Next, other functions in computer-assisted part programming, those are specifying cutting speeds, designating cutter size, specifying tolerances, naming the program, and identifying the machine tool. That means up to now we are discussing what are the important functions in CAPP. In these other functions, miscellaneous functions, those are specifying cutting speeds or in RPMs, designating cutter sizes. Cutter sizing means including of tool offsets. Next, tolerances. For producing any part, we are giving tolerances or allowances plus or minus 0.0 something, 0.02 or 0.01. Those are the allowances. Naming the program, identifying the machine tool. Next, there are 4 basic types of statements in the APT language, automatically programmed tool language. Those are namely geometry statements, motion commands, post-processor statements, auxiliary statements. First one, geometry statements are used to identify or used to define the geometry elements in the comprised part. That means geometry elements, geometry statements are used to define the geometry elements in the particular part. Next, motion command. Motion, we already know that motion is nothing but movement. Motion commands are used to specify the movement of tool path. Next, post-processor statements like speed and feed, spindle speeds and feeds. Next, auxiliary statements. Auxiliary statements are nothing but miscellaneous other functions or other statements. Insertion commands in the program accomplish similar functions. Next, APT vocabulary words consists of 6 characteristics. I'll show it to you. In this geometry statement, I'm taking a word here. We know that, already know that a word, any word consists of some letters. In this symbol, SYMBOL, 1, 2, 3, 4, 5, 6. Symbol word consists of 6 letters or 6 characters. That equal to, first one is the subject. Symbol is a geometry type and then descriptive data. Here P1 is the point, then subject, after that description. Point is the major word and description is the minor word. 20,0 is the x direction traveling distance, y direction traveling distance 40.0, z direction 60.0. Then a symbol can be maybe consists of 6 or fewer alphabetical and numerical characteristics, at least one of which must be alphabetical. That means these are the some other characteristics of geometry statements. P1 permissible. Those are here I am showing that those are permissible or not permissible. Okay. Next, in previous slide we are discussing about geometry statements of points. First one is point. Second one. Okay, first one is geometry statement. In this, I'm discussing about point. Point is designating its x direction distance, y direction distance, and z direction coordinate. P1 is point. It has 50.0, 15.0, 10.0, 25.0 in x direction, y direction, z direction. As the intersection of two intersecting lines, here I am showing that P2 is the point intersection of L1 and L2. L1 and L2 is nothing but intersection of INT is nothing but intersection of L1, line 1 and L2. I'm taking two lines here. It intersects by using of point P2. I'm taking two lines here intersecting by a cross line. Then it has 2 points P1 and P2. I'm telling that P2 is the point intersection of two lines L1 and L2. Next, lines. A line in APT is considered to be infinite length in both directions. 2 points through which it passes. L1 line. Single line passes through P3 and P4. Then passes through point P5 and parallel to another line, L3. Single line L1 is passes through P3, P4, and then it passes through the point P5 and parallel to another line L3. I am taking here line 1 and line 3 that has been previously defined L1, L2, L3. Next, plane. A plane can be defined by the following. Okay, we already know that. Here I am taking example of triangle. Triangle having three points. That means if we take a triangle, then it have 3 points P1, P2, P3. Bottom plane and cone type P1, P2, P3. Plane is generated by using of 3 points. Those are must be non-collinear. Passes through point P2 and parallel to another plane P1, PL1. Next, circle. Circle having 2 points and 1 arc. Starting point, ending point, and center radius. Circle C1 equal to circle by center P1 and radius 25.0. 3 points through which it passes. C2 is circular in P4, P5, P6. Motion commands. Previously we discussed about motion commands are used to specify the movement of toolpath. Next, the motion commands are go to and ptarg. Those are used to indicate the symbol assigned to starting point. Another way to make this statement is the following: from minus 20.0, minus 20.0 in x direction, y direction, z direction is 0. Next, point to point motion. There are two commands, go to and god LTA. Go to in point 2 in x direction, y direction, z direction. Next, god LTA, x direction, y direction, z direction. Traveling distance. It is the subject and description. Subject description. Motion commands are used to specify only the movement of toolpath. Next, coming to this one, I'm taking a plane here. You have 3 surfaces. One is drive surface, part surface, check surface. In this, I'm taking single machine tool here, and I'm showing the cutter motion, and this one is the cutter. So in these 3 surfaces, I'm showing that 3 surfaces. Drive surface is used for guiding the side of the cutter. That means drive surface is used for guiding the side part. That means it's showing about the side part of the machine tool. Part surface, it pictures like a plane, but it shows about the bottom part of the machine tool. Next, check surface. Check surface is used to stop the forward motion of the machine tool. That means check surface, like it acts like a barrier. It acts like a barrier to stop the forward motion of the machine tool. Next, APT modified words. To on past. To on past. That means if any part be taken for doing some operation on that, first of all, I'm taking one part for producing some operations on that. In previous slide, we are discussing about point-to-point command method. That means the machine tools traveling from one point to another point. This one is in this I am showing like round balls here, A, B. First of all, the machine tool starts from point A. After then, it travels from point A to point B. That means point A to point B. It is modified word of to. It is traveling from point A to B. In this stopping location of cutter, that means the cutter, machine tool cutter, starts from point A to point B and travels up to now. And then it travels or extends from point A to B and some long distance on. Second one is the modified word of on. After that, fast. Fast means it elongates from point B to outside. In this, I am showing the difference between the modified word of on and past. Next, tan 2. Tan 2 is nothing but drive surface is tangent to the check surface. Drive surface is tangent to the check surface. Drive surface is, that means it shows the side part of the machine tool. Check surface acts like a barrier and stop the forward motion of machine tool. These are the some statements or some commands or instructions. Go left, opposite, go right, go back and go forward, go up and go down. These are the some commands or the, some statements. Next, coming to third one, post-processor statements. Post-processor statements are unit per mm, indicate that the specified units used in program in inches. That means units we are taking in inches or mm. Next, intol. Intol means tolerance, inside tolerance or inward tolerance. Intol indicates inside or inward tolerance. That means 0.02. Next, outward tolerance 0.02. Next, cutter diameter 20.0 defines cutter diameter of tool path offset calculation. Next, spindle speed 1000. 1000 is the spindle speed, rotates in clockwise direction. Spindle off stops the spindle rotation. Feed rate, rapid changes, coolant, flood or mist. Load delay. Next, auxiliary statements. Auxiliary statements means miscellaneous statements. In this, we are showing some of the statements like machine clear print or cutter location print. Remark. FI indicates the end of an APT program. Cutter location print, which is used to print the outer, that means print out the cutter location sequence. Machine permits the part programmer to specify the post processor. Okay, thank you all.